Hello, and welcome to another episode of The Agent is In. We are on episode 51, and we've got another special guest with us here today, Jay Goldberg, who is going to talk to us a little bit about data-driven configuration with the new upcoming function, class filter data. Jay, could you introduce yourself?
Absolutely. Should I start sharing my screen? Because there's an introduction
Yeah, let's do that.
right there in
Just
the
hop
deck.
right
Let's see. Okay,
in. Great.
there you go. So my name is Jay Goldberg, and I spend a lot less time these days on configuration management. And using data-driven configuration has allowed me to move from using code for system configuration to using configuration files instead. So I'm going to introduce myself, tell you why we did this, what it even means, and how CFEngine's new class filter data function can help you do this too. So a little bit about me. Um, just want to check to make sure that the slide advanced. When I tested this yesterday, there was a little hiccups with that.
Yeah, I see it.
That
Those are
looks
some
good.
very specific dates, though.
Yeah. So I've been doing I'm Jay Goldberg. I am an engineer at Two Sigma, a financial sciences firm in New York that focuses on finding value in the world's data. And I'm part of the team that engineers our storage solutions and our Linux platform. So for the street cred, I used to develop Unix at AT&T, IBM, and Unix System Labs. Um, I've been building and automating infrastructure for 25 years, and I realized, like when I put this deck together, that's like greater than half the epoch, which is why I gave timestamp numbers here. Um, Back in 1996, when I was looking how to do configuration management before building my own thing, I read about this cool project coming out of the University of Oslo. And it took me 14 years to revisit that, and I'm now fully on board. And so here at Two Sigma, we use we use CFEngine to do our system level configuration management. And I'm going to say a little bit about how we do that and how we are moving to use class filter data to do that. But speaking of Two Sigma, my compliance department requires this next slide. So this is just a disclaimer that this is not about investment advice, et cetera, et cetera, et cetera. Um, so let me jump right in. If is this a good time to jump right into the presentation, or Nick, is there more
Yeah,
that we can?
absolutely. If we've given your legal department enough time to fully get the effect, yeah, let's go.
Okay, cool. So, I want to say a little something first about the principle of least configuration. I think anybody who works with security knows about the principle of least privilege. And so, we've changed over the years how we deliver compute platforms. I'm sure that folks who've been at this a long time were around when people were saying like, "Oh, you're never going to put me on a VM. I need bare metal," and then they were saying, "Oh, you're never going to put me on a container. I need a VM." And now we deliver compute platforms in a lot of different ways. So we have like a lot of short-lived VMs and containers in addition to traditional bare metal. And some of the platforms aren't that well suited to what we had been doing with our configuration management software. In 2018 at Config Management Camp, Mark Burgess gave a talk, and there was a lot in there about timescales, and that was kind of just what I needed at the time. I encourage anybody to go. There's a YouTube channel for the Config Management Camp, and Mark Burgess's talk in 2018 um, for me made an enormous difference in how I think about this stuff. So I started thinking about timescales and what this means for configuration management. Very little needs to change quickly on our systems, and mostly to react to customer needs. Some things, only get configured when you change the environment, like you add a new data center or you like rejig how you're going to do DNS instead of, like you move to Anycast or something like that. And then some things like really do need to react very, very quickly to customer requests. So, we had to come up with a way to approach system configuration so that like all of our platforms are based on the same what we call the base platform, the way Linux looks around our company. And all of our platforms work in the default case. And then we just do the smallest amount of customization possible to make things, to make everything appropriate for use. So I always say to folks when they ask me what I do for a living is, I make tens of thousands of Linux computers look the same to the people who have to manage them and look like something special to the people who have to use them to make money for our customers. So we came up with some new design patterns to enable this. So, adapting our config management patterns to meet these timescales. Um, we use packages for very slow-moving changes. Like if there's, something that can roll out over the course of, weeks, we'll use packaging for things that we don't care that we don't care how fast they move. So, um, and what our pattern for this is, like there might be an upstream package, like like think about Unbound, the local DNS caching server, right? That we use. Um, so there's a package, and we care about a custom configuration for that. So we have a company-specific package that depends on that upstream package. So basically, our internal build is based on a lot of internally built package that are dependency slash configuration packages. And we use Debian, so we can use, if anybody uses Debian, there is this facility called dpackage divert, which tells a package system that you can point out some files that you never want to see updated by the packaging system. So that saves CFEngine a lot of work. And I'll tell you how that, I'll tell you how in a minute. So we prefer atomic updates, and here's what I mean about that. So like some systems like SSH now have an SSH config.d directory. So instead of editing this monolithic ssh.conf file, you can do these atomic drop-ins that provide overrides, and that's a huge win for configuration management. I hope everybody's using that stuff. Systemd units are great for this because they allow atomic overrides via drop-in files as well. So you have the behavior of your system, and then in etc systemd you can drop in some override and change the behavior of something without ever touching the original files. And again, that's all about least configuration for us. So we in our company we have a declarative CMDB. We generate a lot of config files for hosts. So for example, we have like every host has an access.conf pre-generated for it. That's based on our self-server user management of access profiles that users can do for hosts that they own in our CMDB. Also, for example, if you own a host, you will be in a local group that's defined on the host called tech owners, and you will have sudo rules that are based on that. So there's things that you can do with your host that you can do on your host as root without giving you all the keys to the kingdom. You can reboot your host and run like the full bore configuration management, like run CFEngine with all the bells and whistles to make sure your host is what it should be. And for the most case, CFEngine just runs quickly and quietly in the background. We do our overall system configuration mostly at provisioning time, and very little changes ongoingly. So it could be that we're changing how we do something, so we migrate something in our CFEngine policy, which is now our CFEngine configuration. And users' intentions then can get realized really, really quickly. If somebody makes a change in their CMDB, within 5 minutes, that change is realized on their hosts. So we moved from a functional approach to a data-driven approach to configuration management. So, most Unix-like systems run on things like files, packages, and services. It's really, a truly reductionist approach could do everything with files because it's files all the way down. So our prior, let's call it functional approach, was we solved problems organized by functional area. So for example, we would have a CFEngine policy for setting up Kerberos, one for setting up PAM, one for setting up SSH, one for setting up AutoFS. And we had 110 policies that did the same things over and over, like add a package, manage a configuration, ensure a service is running. And like if that package updated, then the CFEngine would have to come along and say, oh, I need to replace those configuration files that the package had installed for us. So the fact that we can use depackage divert in Debian um, makes it so that CFEngine has less to fix when a package updates, because if CFEngine now owns that file, reinstalling a package won't reinstall it. So our current approach is data-driven, and like this solves problems that are organized by the atoms of a system. So we render templates, we copy files, we manage symlinks, and we have now 10 policies. Like only 2 of those policies are specific, like managing grub or sysctl.conf.
that
But
are
this still
special.
doesn't, I'm sorry?
Oh yeah, that are like some special edge cases. I was a little bit curious, or maybe you're going to tell us here in a little bit. So when you are kind of doing things like resource based, or files, packages, services,
Yeah.
how are you tying the related data bits back together? Like how do you if if there's a zombie apocalypse and nobody knows anything and a new person walks in, how would that person easily know that, like, in order to configure SSH, I have to touch these 3 or 5 disparate places?
Well, to configure so this is the kind of the like in the realm of our base platform team.
Okay.
So the base platform team, we have a lot of we have a lot of continuity and a reasonable number of engineers who know how this stuff works, and of course, great documentation throughout.
Okay.
So um, one of the things that is clear about doing a data-driven configuration and using packages for part of this stuff is like the complexity is going to be somewhere,
Mm-hmm.
right? So if we take the complexity out of config management, out of CFEngine,
Mm-hmm.
and put the complex, and put some of that complexity aside into packages, then that's part of what our reliability engineering teams and our platform engineering teams review on a weekly basis. So, part of this approach um, is requires great communication. And in our company, we have a weekly config management scrum where the interested parties from the platform engineering teams and the reliability engineering teams come together to talk about what happened in config management last week, what's going out this week
Mm-hmm.
through our weekly release process, and what we're concerned about and what we're thinking about for if we're going forward, and problems that we can work with each other on about how we're looking to approach, looking to approach something that we're going to tackle in the future.
Cool. How long
So
did it take you to transition? So this change from 110 policies to 10. How long did that transition take you?
um, depends on how you measure time, right? So we used every time Debian comes out with a new release, we have a new release of our base platform. So we used an upcoming Debian release as the thing that moved us to the new place. So it took a couple of months to come up with the approach and the policy, and how that then goes into how that then requires package management, so that we could do a real reductionist approach to config management.
Mm-hmm.
Um, but we kept running our previous version of the base platform on that functional approach
Mm-hmm.
to CFEngine. And when we released the new version of the base platform, with which we implemented this, it was like a clean break, and it's been just much easier to maintain going forward.
Cool. So really, just a few months of planning work, and then was that how long it took to do the full deployment? Just a couple of months, the whole transition, or was it a couple of months of baking and then got to wait a few more months and then the transition happened?
So we are we have a like a calendar for supporting a platform. So we are not going to support a version of Debian after it goes out of LTS. So what that means for us is we'll introduce a new version of the base platform pretty much the day it's released. So we use pre-release versions of Debian to work on the next version of our base platform. So it's ready to go.
Cool.
In our company, we have um, basically a monorepo driven development. So all of our software has to build on the new version of the base platform before we can tell people that they need to upgrade to the new base platform. And there's a command that they run on their Linux host that just says, oh, upgrade in place, and it kind of preserves important things on the host and installs the new version of the base platform. And when that host reboots, it then gets its new deployments that were released through our release system that's based on the code bases in the monorepo.
Very cool. All
So
right,
we
sorry, I'll
now
stop
have,
interrupting you for a
yeah,
little bit.
no, that's okay. So we now have about 10 policies, but this doesn't really tell you yet why we think of this as data-driven configuration.
Mhm.
So the logic in our config management policies manages these atoms or building blocks of the um, of the system, and what we do with those things are based on configuration files. So, I'm going to give a lot of credit to Neil Watson here. If anybody has ever looked at EFL, Neil's EFL libraries have been doing something like this for a long time. I imagine there's other folks doing this as well. So, I want to just run through what policies we're left with in our data-driven configuration. So there are a couple of common bundles that parse some things like subnet to class and hostname to class management, and then our CMDB generated class files, and that go through and set classes. There's two more in here that aren't listed. One specifically for setting a root password hash, and one for at the end of the run, writing a file with all the classes that were set on the host when CFEngine ran. And the rest of it mostly works on the elements of the operating system, like files, directories, templates, symlinks, and packages. So first I'm going to give you an example of what our configuration files look like this, and then I'll show you how to do it with the help of this new feature that's making its debut in CFEngine 3.7. 3.27. 3.7 was a long time ago. That's ancient history. So Nick, I got that right? It's
Yes.
3.27 for
Yeah,
this
it's already
feature?
merged to master. So if you grab nightly packages, this functionality is already there. So
Right.
327, it'll be coming.
Yeah, so I've had the privilege of working with these nightly builds so that I could test this stuff and come up with these examples so that we can rework our code base to use class filter data. So in our CFEngine policy directory tree, we have a configuration directory which has a directory of CSV-like files in them. So for each of our data-driven policies, there's a CSV file like item.csv, and then an item.d directory that may contain multiple files. And this kind of lets us logically move things together, like so, or manage things together. So like if in the example that's on the screen, this is our CSV. I call it a CSV file. It's absolutely not an RFC compliant CSV file that manages AutoFS. And this is just a kind of a subset of what's in there. But
So just
instead of having one file where we're managing absolutely everything, like all the symlinks on the system, we can have atomically In the same way that we manage elements of the system atomically, we have a configuration that we manage atomically, that all the ONFS stuff would go in this CSV file. I'm sorry, Nick, you were going to ask.
I was just going to interrupt again and say, so you'll have, symlinks that relate to AutoFS, symlinks that relate to Apache, symlinks that relate to each different service. Yeah.
Exactly. So that lets us very simply manage, manage a small chunk of configuration in a way that reduces risk quite a lot.
So that you don't blow out the human's context of what they're having to look at, everything. Yeah. Very good.
Correct. And that was one of the problems that we really had with our functional approach before, is that there was a lot of logic in our policy.
Mm-hmm.
And that logic, like, we would basically have one functional area could potentially trip over another functional area. And this compartmentalizes stuff really, really nicely for us. So, like, the way we do it keeps the individual files from getting too complex. We can organize the configurations in a way that makes sense for us. And CSV files don't have any overall syntax. And so, like, an issue with one line in the way we've implemented this doesn't invalidate the whole file, but it will throw an error.
That was something that I remember, like from a long time ago. We talked a lot about this notion of wanting to be able to continue doing the right thing for as much as you can know about. And that was one of the reasons why um, we worked on the class filter CSV functionality, because it was tolerant to being screwed up at some point. But up till that point, you could still extract some value.
Correct. And that was a more that was a more direct, a request that was almost a direct translation of what we were already doing in policy.
Mm-hmm.
And then as a result of that, at some level, I feel like like I got what I asked for, but not what I wanted, because the CSV libraries in CFEngine and class filter CSV requires reading a single CSV file,
Mm-hmm.
and that single CSV file has to be RFC compliant. And an RFC compliant CSV file ends in CRLF. So for anybody who lives their life on a Linux system, that they have to remember to run, or we have to have a Git hook to run, to run
Unix to DOS or
Unix to
DDoS.
DOS. Right, exactly. Or just in general to pre-process that stuff. So I did have some Git pre-commit hooks that would do that sort of processing for us. Um, but
So then, I'm
since
sorry.
we were already since we were already processing these CSV files using a module that delivered us a beautiful data container, class filter data becomes a thing that's much more general purpose, because you can use read CSV, read JSON, read YAML, like anything that you want to read,
Mm-hmm.
you can read now into a data container, whether you do it the way I do it with a module, or whether you pre-process stuff and use read JSON.
Just kind of digging back into your example here again. So what we're looking at here, this format that you've got semicolon separated.
Yep.
Um, so you've got the class expression, because I see that there's like nots and ands in there. So it's a full expression
Yes.
to match the context. And then you have the link where it's targeting, and then a command. I guess the command runs if the promise is repaired.
If the promise is repaired, right? That's one of the patterns in how we do our data-driven
Mm-hmm.
configuration. Almost everything that we do has an optional command. With
Okay.
packages, no. But because there may be something that you need to do in order to affect the change
Mm-hmm.
when you've changed that configuration. So, like in this case, you update etc auto.master.d, and if that has changed, you do a systemctl restart autofs. And I have a policy example coming up that shows you how we do that. And we love our classes generic for this.
I also see here that you've got CFEngine variables inside of the data.
Correct. So
So
that is, yep, I'm
yeah,
sorry.
yeah, it's like dynamic data at that point.
Correct. So it's data that we know we have somewhere um, somewhere in our CFEngine policy.
Context or
So
yeah, yeah.
so
Mhm.
so one of the things, so like you see this thing says etcts files dot pop. So we have a bunch of things that we know that hosts know about themselves. So we have like an etcts location, an etcts hardware info, because TS for two sigma, of course. So POP, our point of presence or our data center. So like every host knows what data center it's in, and we can use that as part of our configuration here. And I'll show you how that gets implemented as we go through the policy that I'm about to present. But I think we've maybe even covered like why class filter data,
Yeah.
but but y'all don't know the history of it. So like I broke my cardinal rule of not trying to use CFEngine's domain specific language as a general purpose programming language. I wrote a really ugly library. I mean, it's perfectly fine. It's pure CFEngine, but for people who aren't already like really fluent in CFEngine, it's difficult to follow. So there's basically like 10 times more comments than code in this library. And I thought like, hey, this should be it could probably be a function in CFEngine. So it didn't seem like too much of a reach for somebody smarter than me to implement this. And so like lots of thanks to Nick, Vratislav, Lars, and I don't know who else from CFEngine did the original work on class filter CSV and now on class filter data. So, again, the CSV stuff works great, gave us a performance boost and simplified our code quite a lot. And, no offense to Windows, but no self-respecting Linux engineer is going to write those files with a CRLF termination. So we get some advantages from using class filter data for this. Um, so here's the syntax. Like this should be no surprise because it's right out of the manual, but you probably don't have the manual yet because right now this documentation is in the Jira. So class filter data takes a data container as an argument, and it reduces it to a data container that's filtered by class. So basically, if the class expression doesn't evaluate to true on the host on which the policy is running, then class filter data takes that out of the data container. So um, there are a couple kinds of data structures that are allowed in this right now because clearly with a data container you can go any shape you want. Um, with a lot of conversations with the CFEngine engineering team, um, we settled on the initial implementation being an array of objects or an array of arrays. So an array of arrays might be like the equivalent of a CSV file that isn't, isn't parsed into a JSON object using a header, right? So class filter CSV, the header is optional. And if you have a header, it will parse that into an array of objects, and you can say what field number in that, what field in that object is the thing that defines classes. And if you don't have a header, you just get an array of arrays, and you can say what number, like what number field is the field that has the classes in it. And so the important thing to provide is the class field. So it's the name or the number of the field that contains the class statements that class filter data will filter from. And we we generally use map data alongside of this for some additional functionality. So like our CSV files, just as a way that we can logically think about them, we order them from the least specific case to the most specific case. So, put the case for any or for Linux in the first line. And then something like, oh, the host is a container host, or then after that, oh, the host is in a DMZ. Um, and so we use this map data. Oh, I didn't even change my if var class to an if, so y'all see how old my code is. Um, so what we do with the ability to use a map data with JSON, use map data with a JSON pipe is we sort the data by index. We put it in reverse order, and so when the policy is going through the data that was filtered by class filter data, it sees the most specific thing first. So it tries to implement that. And then, as I said, we love our classes generic. So classes generic says if that promise has been repaired or kept, then I'm done, right? I'm not going to do any more general case. So you keep trying from the specific case to the most general case, and you'll eventually land at the most general case and do that thing. So, you'll see an example coming up of how we configure unbound for different use cases. And we'll start with just the CSV file here. So in our template configuration directory, you can see here that we have like the first class statement is any. So any of our hosts gets the template from the default unbound default directory. So that first column is any legal class math that could be parsed by if or if var class. If, like me, you haven't replaced all your if var classes in your policy. So we use Unbound as local caching DNS server on every Linux host. So we have a different template for our container hosts, and that's our Kubernetes workers that provide our our huge farm of just worker nodes. And then we use a different template for our hosts in the DMZ, which are internal and external mail exchanger hosts. And you see there it's MXI, the internal, or the outbound, the inbound or outbound MX hosts. And that uses the DMZ configuration. So, this is a good example for us of like what a CSV file would look like. And I used a totally different example that translates well to being presented in a slide deck. And that was rendering sysctl.conf from a template. So I'm going to walk you through that so you can see how class filter data works. So here's our CSV file for sysctl.csv. So some class, some variable in sysctl.conf gets some value. So we have some special hosts that need a lot more iNotify, a lot more iNotify event and watches configured, and because they're looking at changes in data files on the system. And then you can see down at the bottom we have like a database server. We'll have a larger NetDev backlog that's twice the size of our normal Linux systems. So, to simplify the example, I pre-process this into a JSON file. And in fact, I think there might be some advantage to me pre-processing the CSV file into a JSON file and using that going forward, like delivering the JSON, the CSV files, but also delivering the JSON files and having our policy use the JSON file, because this is fairly easy to look at, right? So here's the JSON equivalent, and again, we because we like our setup where we manage like item.csv and item.d specific thing.csv fits in with our management style. Here is everything, for this particular thing, there was only one config file, but for any other set of CSV files in our environment, it will basically be processed as one data container, which will look about like this. And you can see that we add an index to this so that we know, we could if CFEngine didn't already preserve sort order for us, we could sort by that index number. So what we're going to do here is now process a data file with all the possible values for sysctl.conf for all of our hosts based on some class math. And since CFEngine examples in the documentation are notoriously generic, here's a real life policy example that I hope you find helpful. So I have this policy split into 3 slides because, like I'm not as confident as Nick in my ability to share my terminal and be in Emacs org mode and just run all the things directly in real time. So here's this bundle agent do sysctl. So in the vars section, we define a template and a target for the template. And then we define this canonified target so that we have something that we can use in class statements going forward. So we read the data, that JSON file into sysctl raw using read JSON. And to be fair, what I really should be doing here is this is kind of like for stepwise readability, but you can say instead of class filter data sysctl raw, you can say class filter data where the data is read JSON of that file. And in fact, there at the end, where I say sysctl data is data expand, which is the thing that expands the CFEngine variables. So since, as you've seen, we use CFEngine variables in the configuration data, so I'm doing this stepwise in here so you can kind of see it better, but you could actually say, class filter data expand read JSON, like each is an argument to the other, as nested arguments, and then you have, something that may be a little difficult to read, but it'd be much more efficient to execute. I haven't done the benchmarking of doing it both ways, so I'll share that with Nick when I've done that benchmarking. So I can see whether I should opt for readability or opt for efficiency. So now for the rest of the actual policy, there's file section where we create a file by editing a template with a mustache template. And here I am with my classes generic. So all of our general data-driven policies use classes generic, so we know if a promise is kept or repaired. And now in the command section here, we can run a restart of systemd sysctl service if promise repaired template of the canonical of the canonified target file. So if anybody if anybody's not familiar with classes generic, it's a really nice way to see at the end of like after a promise, if you use classes generic, you can see, was that promise kept? Was that promise repaired? And there is one for broken. I don't know I don't know off the top of my head what that one's called. I bet Nick does.
Broken. There's one for reached.
Reached. Oh, there you go. So it was even reached. Okay, that's not one that I use.
Yeah, reached is great if you for the times when you have something that you want to attempt, but you don't really care what the result is if it succeeds or fails. So kind of a rare, but it's a fun one.
Okay, so basically what this says is, canonify, restart the service if the promise was repaired. So it's great. You don't have to we don't restart the service every time we run. We just know that the promise was repaired. We can restart the service then. And there's a little more policy here because, I'm really old school, or maybe unevolved, I think is the right word for it, where I like print statements for debugging. And my CFEngine policy is no different. So I have my data-driven debug class. So if I run CFEngine with data-driven debug, I get to see everything. And so I did that for you. And so here's what happens when we run this code with that debug class set. So here is the debug statement that says, here's what the raw sysctl data was. So you can see this, and I cheated a little bit, and I highlight the stuff in green that that evaluates to true and highlighted the stuff in red. So you can see you're looking for 6, 7, and 8 to be gone in the next slide when I show you the filtered data. My apologies for anybody who's colorblind and can't tell the difference between the green and the red. So here we go. Afterwards, the filtered sysctl data, as reported, is missing. Um, it's missing 6, 7, and 9. Was that the right numbers?
Yeah.
Yeah. So 6, 7, and 9 are now gone. And next I'm going to show you the template and the resulting sysctl.conf file. So really simple template. Like we put our, we try to make sure that for any well-meaning reliability engineer who wants to hand edit a file, that they know that the file is managed by CFEngine, so that if you manually change that, um, you better make it immutable if you really mean it, or you should be working with the configuration if this is something that's not like a 1-minute emergency that you have to fix. And then the resulting file is just the template rendered with the variable equals value. Um, so we get a lot of benefits from having reduced our configuration management to these few data-driven policies.
Very nice.
And the most obvious benefits for us are operational, right? So, now everybody who cares about configuration management, they can participate without having to be an expert in CFEngine. So we have like maybe a dozen folks here in the company who make configuration changes, and probably about 4 people who are good enough at coding in CFEngine to mess around with the real logic of the machinery,
Mm-hmm.
where everything used to fall to those 4 experts and things took
Mm-hmm.
a lot longer.
Mm-hmm.
Um, like our changes are much safer. There's no code. They take very little effort. And we have our, testing harnesses for making sure that these things do the right thing before and after. Um, and one of the things that I can point to, like some real data, is that we used to do like 12 to 15 hot fixes per year when we were doing our functional approach. Like there were a lot of hot fixes. We would
So
break
what's a
we would
hot
break
fix? A change in the middle of the day, or like?
a change that had to go out outside of our normal release cycle. So we have a lot of automation um, around the release of our CFEngine code. So um, coming soon to a config management camp near you, hopefully in 2026, is a much fuller explanation of how we do our release process and how we reduce the blast radius here at 2 Sigma. So the the as everybody knows, right, the ability to make changes across your whole environment with like a little piece of code is an amazingly powerful thing, right? And it can lead to some really bad events if you do things wrong. I've lived through some bad events at previous places where somebody just like, oh, removed Etsy shadow on every host. That was like one of the bad ones for me. Um, So, you imagine you have to hotfix stuff. And in fact, way long time before I got here, somebody actually removed dev null in policy. So years ago, we had like one of our policies was ensure that dev null is there. And, we were basically running every 5 minutes on every host. Like, if dev null isn't there, create a character special file, and then you'll have dev null. Because that was the only way we could fix it at that time, because you couldn't even log into the hosts. So we've gone from having 12 to 15 hotfixes per year to maybe 2 per year, maybe 2 or 3. So it's a lot. It's a lot safer. Like the changes that we do are a lot safer, and people feel more comfortable making
Mm-hmm.
the changes because there's not a lot of logic to reason about. But then another great benefit that we got was enormously reduced complexity of the code base and improved performance of the code base. So before we did this, I said we did this. We did this like break from, okay, one version of the base platform to the next version of the base platform. We implemented this change. So here's the before and after. So our functional code base was over 19,000 lines of code. and then we moved to a little over 1,300 lines of code. So it's 93% less code. And what I'm really looking forward to is what happens when I have fully migrated over to the class filter data, because that's going to further reduce by, probably by a couple hundred lines of code, um, how complex my policy is. And we went from running in, at times over 60 seconds to run through the policy to less than 2 seconds. And one of the things when I got here, CFEngine had a bad name at my company because it was noticeably impacting performance in some hosts. And now nobody even thinks about it anymore. It's not even part of anybody's vocabulary. So it's in some ways it's really good not to be known. So we got out of the way. This other let's see. Um, One thing I wanted to add to this was when I rewrote our policies using class filter CSV instead of um, our like processing the CSV files in policy. I saved yet another 21% of system performance running policy. It's 21% over the
Over what we see here.
the fast version. So it's over 20% faster than my good current state.
Wow.
Yeah,
Wow.
so it's terrific. Like to do stuff in C functions that CFEngine already knows how to do, and then assemble that stuff into a function that makes it easy for us to parse through our data containers. It's fantastic. Um,
And
the
that's your
other oh,
policy run. Complete policy run in 2 seconds.
complete. That's the right, and that's not the one that's going to go through and do do the depackage
Yeah.
update, right? So
Mhm.
it's not pulling in
Not
all
doing
that data,
packages,
but that
right.
but that's the normal like not installing packages. So we actually have some gates around what changes CFEngine is able to make, because our systems participate in financial markets, so we tend not to want to make changes during the trading day.
Yeah.
So we have this concept um, of the change window,
Mhm.
and hosts in different regions or responsible for different regions have their defined change windows.
Mhm.
And so when CFEngine is running in a change window, oh, then I can, you know, restart massive things. I can change the kernel. I can add packages. I can restart crazy services.
And because of your CMDB stuff, you've also got the ability to be pretty specific about when the change window for hosts is.
Correct. I mean, that's basically in our world that runs by um, that runs by region.
Hmm.
Um, and we have configuration that is part of the config manager, part of our CSV files
Hmm.
that says, oh, how often do you want to run, how often are you going to run CFEngine? So most hosts run it every 5 minutes.
Hmm.
Some of our very important production trading hosts only run it during change window. And I think Martin has a hand up.
Yeah.
Okay, well, Jay, I like the presentation very, very much. And you triggered me now because of this CMDB kind of relationship. So one of the gains you show is not only the concept of using this type of policy, but also avoiding to run unnecessary code. Is that true?
That is correct. Yeah, it's
Okay.
it's you only you like we because of the reliance that we have uh, on uh, on classes generic. Like we can run commands and make changes only when they're needed. So that
Yeah.
also helps.
Okay.
There's another great benefit that we got here, and I know we're running low on time, but I want to take a quick second to say that our ability to do reporting comes out of having very, very few policies. So this is a lot to look at, but here we have this thing. If you look under methods, there's this class gate called mode report and mode declare. So if you are running in a reporting mode, CFEngine, our policy will make all the changes that you want in a mock root directory. And there's two reporting modes. One is show me a diff, like if I hadn't run CFEngine, if I have like our security team, for example, is very concerned about being in control of their hosts. So they may not want to run this all the time, but they have a reporting mode that says, if I run CFEngine now, here's what's going to change. And then there's another mode which just makes a manifest of absolutely everything that CFEngine manages on the host by making changes in a mock root directory. So the real benefit of this, like I asked this, I implemented this because in a previous life I used to have to answer the question, well, what is CFEngine going to do to my host when you run it? So this answers that question, but nobody here really cares about that. The real benefit is that I now have a simple script for testing changes to policy configurations or even software versions, right? I can compare manifests. And if the only thing that changed is the timestamp in the manifest, my change is a no-op. So this is great for CFEngine version upgrades. It used to take us a long time to make sure that like a new version of CFEngine was functionally equivalent. It didn't break anything in our complex policy. And now, like I know the answer to that in about 5 minutes, and like I can just update CFEngine policy. I'm sorry, CFEngine versions anytime I want, and I can also see. I can also provide evidence of testing for my ticketing system with the diff of a manifest.
Jay, I'm just curious, does this reporting diff leverage the simulate mode?
It does not, because we wrote this before simulate mode, which is, I think, one of the drivers of simulate mode. Mm-hmm. So I have to take a look more at what simulate mode can do for us.
Yeah, well, it can operate in a change root. So for file editing, it just does that on itself. It'll copy the source file in. Like if the file exists on the system, it'll copy it into the change roots and then apply the stuff on top of that. So I mean, it's primarily for files. I think packages, it just says what it would do.
Right.
But
right, that's what ours does as well. Like we don't install the package in a true rooted environment. We do the, again, because it's only one, because it's such a small number of policies. Like we can do that. We can take that approach. And so, I know it's quite late, and I did want to ask if anybody has questions for me, and I also wanted to ask you all some questions.
So I also have this. I grabbed your example since you sent me the slides yesterday. I do have your slides running. So if anybody wants to poke at this, or your sysctl policy running. So if anybody wants to poke at it and see it actually execute, we can totally do that as well. So yeah, anybody have any questions, or is anybody else using data-driven policies? Either stuff from Neil's the EFL. That's still out. I know Surf Sarah, Bass at Surf Sarah, he's got SCL, the Surf Sarah configuration library, which uses data-driven stuff.
Well, you could make a difference between internal data-driven policies and external data-driven policies.
Yeah.
So the way I see it, Jay presented policies, and those are concerning the external data from my point of view. Like, for instance, our friend from Norway, the guy with Italian name, I forgot about it. He also talks about external data. But in the day and age that I was using dynamic CFEngine, I was using the internal variables to steer the policies. Also reducing policy processing.
Yeah. Yeah, doing a lot, separating the data out into separate variables is kind of the first thing. And then, along the way, we've gained a whole bunch of different,
I
capabilities,
discussed it
parsing data
with
structure.
Mark Brantley, of course, but I don't believe he's a big fan of this concept.
Of data-driven?
Yeah.
Oh, I think he has no issue with it. I mean, there's old libraries of stuff that's very similar to EFL. That's data driven for CFEngine. I mean, so here I'm gonna go ahead and share and take over your slide. It's so pretty, but
that's okay.
Hey, thank you. It was a
I
great
can't help
presentation.
myself.
Well, thank you. I really, I just, before Nick fully takes over, I do want to thank everybody for, for being interested in this and for having a look at this. I think on that last slide, if anybody wants to reach out to me, Nick can, if you know how to get in touch with Nick and you want to get in touch with me, Nick can get in touch with me and connect us. But if anybody wants to talk over approaches or talk over, how to implement something like this, I'm really, really happy to have that conversation.
I think you should do this presentation again in Ghent next year.
I'm planning on doing this one in Ghent and also my long-awaited, how do we reduce the risk of having such a powerful tool at our disposal? What we refer to here as reducing the blast radius of, of what's possible to blow up in your environment.
Mm-hmm.
Of which this is actually a really huge part.
I was going to look in. So this is let's go to, I guess, the raw. Is this large enough to see? To read? Yeah.
Yeah, it's fine with me if I expand my screen.
Okay. So I guess kind of going back to the question I was asking about earlier, like how do you link these together? And it's basically in your environment, it's just well socialized as the way that you guys operate. But there was something that kind of came to my mind when I was looking at the data and I was thinking about the language. We've got this promiser stakeholder field, right? Which you can just use to kind of say that this is related to somebody else, or more specifically, this thing cares about this promise. So when I'm looking at this data, that's one of the things that comes to my mind is I would probably want to add a field in here that maps to, in the language, the promiser, the stakeholder, so that I could come in here and say, well, I know that you're doing things like autofs.csv. So everything in this file is related to autofs. I might go ahead and either extract some information from the file name or add some more data into the data itself to simply say autofs, because inside the language, you can do things like pulling metadata about promisers and related things, and then you can pull together like a graph basically of these kind of related things. So
wow,
just a little sidetrack on that. I also, because I cannot help myself when I read policy, I did take some notes, which maybe we can go over. I don't know. We can go over the notes now, or we can go over the notes later. There's not too many. I think we can go over now. All right.
I think that would be great. I would like to. I don't write near as much policy as you do, Nick.
All right. Well, yeah. So these are a couple things. I started reading the policy. So you are canonifying the target. And I noticed in your policy later, basically, kind of reading ahead, this, I think, was the only place that you used that C target variable. And then, you used it here, and you also used it here. And then here you unnecessarily canonified it again.
Yeah, you're right.
It used to be that you had to do this all the time if you were going to take a string and define a class with CFEngine. But since many versions ago now, modern days, after 3.7, I think, you don't have to explicitly canonify a class on definition. So CFEngine will automatically just canonify the class and define it. It used to warn and do that, and now I think the warning has gone away. So it will just do it for you, which means that you don't have to worry about doing it ahead of time unless you need to check against the class multiple times. Then you're going to have some execution savings from having it pre-computed, I think. Or if you're iterating on a map where you're using the canonified value. But most of the time, I think not needed. Then, as you mentioned when you were talking about it, right? These three statements here can all be just kind of pipelined into a single statement, which could give you,
it's slightly less cool for those debug statements, but once the policy is written,
exactly,
you don't need it.
This is another one that actually I see fairly frequently, and I would say it's a more modern cleanup. 318, 321 maybe, but it used to be that when you're promising a file, if the file didn't exist, you had to explicitly say create true, or else we wouldn't create the file necessarily. But those things have been kind of regularized. So the only time when you need to explicitly specify create true is when you're using edit line, when you're making partial modifications to a file. Anytime that you're using classic templating, mustache templating, file copying, or the content attribute, all of those cases are full file management. And in those cases, you do not need to supply create true. In fact, you might not want to. So using create true concurrently with other methodologies that manage full files, you can end up in a situation where you just get an empty file, right? So if the file doesn't exist on the system and CFEngine runs this promise, it will first of all touch and make sure that the file is going to exist, and then it will try to render this template. But if that template rendering fails, then there will be no content. So it will satisfy as much of the promise statement as it can, leaving you an empty file, which maybe is not what you would want your service to read. So that's one that I would recommend yanking out. And then this one, I think it was just, path or paths.systemctl, use kind of the well-known paths from the standard library. If it's not there, we should add it.
The thing there's another thing in there, Nick, that I see in your notes about body classes results.
Oh yeah.
And this is something that that I don't know. I don't know what that does.
This one. Okay. So body classes results is basically very similar to classes generic. It has two major differences. So number one, it takes two arguments instead of one. The first argument being what the scope for the class that you're going to define. So I like that because I like to kind of be very specific about when I'm defining global classes that other bundles could access, or whether I'm just defining classes inside of a specific bundle. And then the other thing that it does is classes generic defines classes for all these outcomes with both prefixes and suffixes of the state. So it gives you kind of like two different ways to refer to the fact that the promise was repaired or whatever. And body classes results is simplified with that regard. So like, I think the suffix or the prefix stuff is removed. So it's just whatever you feed it, and then it suffixes with the kind of results. In fact, we can hop over. If I go to reference, let's look at the master files policy framework. And what was it that we were looking at there?
It was classes results.
Search results? No.
Yeah, you got it. No, you had it.
I just didn't wait long enough for the results.
No, it says search for results. Don't you click on that? Oh, that's not a link to something. Okay, I'm sorry. I thought that was a link to the results.
Let's see, classes generic. No, I think it's because I'm on the master branch. Because I was going to say that, hey, that documentation is sitting up on the master branch for class filter data. But let me see here. Reference, master files policy framework. That's classes.cf. Where is that? Okay, maybe I'll switch over to classes generic. And in here, then, there.
Prototype results. Yeah, I see it.
Okay, so yeah, so it takes the scope and then the class prefix. So it will define whatever you give it underscore kept, repaired, not kept, error, failed, denied, timeout, and reached. So reached again is that one that I mentioned. I don't think that generic does reached. Classes generic.
Yeah, also the results is, I think it's a much more mnemonically better.
Yeah, it reads better. Say. Yeah, I think it.
Yes, sort of like if instead of if var class.
Mm-hmm. Exactly. Yeah. And you know, it could be arguable that we should maybe add one that's like global results or something, or private results or whatever, like so that scope isn't tunable on it. Right. Just make one that's like for namespace scoped classes and one that's for bundle scoped classes. I don't know. I almost always define bundle scope classes, keeping it private, like unless I've got a good reason. But using this data-driven methodology, you might have very good reasons for subsequent resources to be keying off of classes from other things. So.
Right. So I think in one of my, like if I have a .cf file that is contains everything for rendering templates, for instance. I have a bunch of bundles in there, and some of those bundles, I would have to look at this, but some of those bundles do care about each other's, about each other's classes. Mm-hmm. So I would probably want to say, this is the TS templates namespace.
Mm-hmm. Mm-hmm. Well, actually, the classes that you define, you would just want to specify as being namespace scoped.
Right.
Because classes generic does all of them as namespace scoped. Let's see here. What else? I did set this up as a build project. So actually, this is how I wired in your stuff, right? So I put all your stuff in this sysctl directory, and this will make it part of the built policy set. This will make sure that the policy files in there are added to inputs. And then this will make sure that this bundle gets run as part of the bundle sequence. And then I did have to replace something in the framework, so I added this overlay to kind of overwrite one of the MPF files with a change that I wanted to do with that. So let me see here. There's this. I think I looked at here, right? I didn't change the policy really. I left all of your stuff the same. And then clear. So CFEngine. Okay. Oh, I probably needed to
tell it to run.
Data driven debug.
Okay.
That's your class, right?
Yep.
And I've got 4, 5, 6, 7, and 9 are missing from the filtered sysctl, just like in your example above. We can look through this and we can say, okay, so these are all the ones that were in context. What was it? 9 DB server. So we could grab that class. Let me hop over to mission portal. Just want to see here. If I jump over to my hub, I could add this class on this specific host. This would be it'll do it in the default lane, I think. I better specify. I can't remember. Yeah, so save that. And then if I run the policy again, now DB server was into context. So, I mean, that basically functions exactly like your CMDB, right? 5 minutes later, you get your data update. This time I set it on this specific one here. I guess I could remove it from there, and then if I did this again, it would drop it. And then if I were to go use groups, I think there's a group already for hubs. I can go down here and just add this data. Default DB server. And then if we just run that again, it should come back. So yeah, very great way to do stuff. And yeah, policy execution in a couple of seconds. I mean, that's really nice. Oh, and yeah, I guess I didn't need to do that because we could just see it straight up on the thing. I did add inventory to inventory the sysctl stuff from the file, but not as fun to look at that. So anyway, yeah, that was great fun. Any other questions, comments before we end the recording and then hang out afterwards if anybody wants to? No? All right. Well, I guess that'll be a wrap for episode 51 of The Agent Is In. Thanks a lot, Jay, for joining us and, sharing your policy with us and talking to us about it. It's great to have you.
No, thanks for having me. It's great to be here.
Awesome.
Yeah. Thank you, Jay.